AI, deep learning and machine learning are being used across multiple industries, as we've demonstrated through our Inside AI programme. One area where it's starting to gather momentum is in climate mapping data, which can show us how land areas have changed over the years. At SCAN, we have the pleasure of working with organisations all over the globe who are using advancements in technology to benefit humanity. OpenGeoHub, a not-for-profit organisation, have collaborated with other agencies using cutting-edge machine learning to create OpenLandMap, a global predictive vegetation and soil mapping system which can now be used by researchers and businesses. OpenLandMap gives land cover classifications and shows conservational changes over the last 20 years. We spoke to Tomislav, Hengl and Leandro Parente from OpenGeoHub to find out more about their data processing problems and the solutions they came up with. Tom, Leandro, thanks so much for both joining us today. Tom, I want to start with you. What exactly is OpenLandMaps?
Yes, thank you. OpenLandMap, it's a data platform. It's a WebGIS solution to explore global data about environment. So it's something comparable to OpenStreetMap, which is a solution to explore like road information and urban areas, etc., but focus on environmental layers.
Could you give us a demonstration and talk us through what we're looking at?
Yes, let me do a little demonstration just to give you an idea what is it for and how does it work. As I said, OpenLandMap is a similar project to OpenStreetMap. I don't know if you heard of OpenStreetMap, but it's kind of an open data project, and it's similar to like Google Maps, except all the data behind here, it's open. And so we made something like that, but it's a focus on environment. So what does it mean, environment? So like first thing from environmental layers, there are a couple of layers which are like standard layers in environmental sciences. So one of them is, for example, land cover. So when you come to OpenLandMap, you can, for example, say, okay, show me, this is my location here. And so the first thing I see on land cover, and I can scroll now back 25, 30 years ago, and I can see how this land cover changed.
Wow.
So I can visualize now the change. And sometimes, if you look at the Europe, many parts of, especially Western Europe, you have this urbanization. So the cities are growing basically. But you get the visual picture of it, and you can see it's a very dynamic world. And everything we created has a URL bookmarking system. So you can share that if you want to talk about some drastic changes, you can share it with your colleague or friend, and you say, look at these changes in urban areas or changes in some other land cover class. I can zoom into something more interesting. Let's go to tropics. And so let's go to Indonesia. So let me zoom in just here. So I'm looking also at changes in the land cover. And if I go back, you can see there is also, unfortunately, there's a lot of cutting of forest, tropical forest, and conversion of this forest into agriculture areas. So what we made a system that you can, zoom to some area where you see, okay, there's some changes. You can see there's some changes here happening.
Yeah.
And so I can zoom in into this area, let's say. And I can then turn on the satellite image, and I can see on that satellite image, I can see that indeed there is a plantation here that just popped up. I could trace it back at which year that plantation came. So wow. That will be 2006 most likely. So I can see that plantation. And then what we did also, we estimated what is the effect of this conversion of that plantation. So we calculate this land degradation indices, and we could estimate what will be, for example, soil carbon loss for that area. And in this case, I will get, let's say, 13 kilogram per square meter. So that's quite a significant loss in carbon. But now we have another project. We're also working on Europe, just Europe. So we're making a kind of OpenLandMap type solution just for Europe. So my colleague Leandro is now going to share the screen, and he's going to show you Europe and the project at 30-meter resolution. So that's way more ambitious. So that's that we're getting now into 10 terabyte data sets and stuff. So I pass it now to my colleague, Leandro.
Excellent. Thank you. Hi, Leandro.
Thank you, hi. So this is like a preliminary version, but in the next month will be online and accessible and free for everyone get and take a look in the data, access it. And basically, this is a a product that we are generating for the whole Europe. And we can see here, there is a lot of data that we are organizing internally, and we are processing and crunch this data to identify the land cover class as pasture, urban areas, and crop areas all over the Europe since 2000. So in the last 20 years. And here you can see this is the an image, satellite image for the whole Europe obtained during the summer. And we can go back to 2000 and we can see all the years in this image. So it's just to show that we have all this data organized and ready to do machine learning and to generate products using it. We have other data too, like the hillshade, so we can see the how is the terrain looks like, and we are using it to training and to classify the land cover. So there is a lot of data that are organized, and I will show the output that we produced. It took 5 days of processing, almost 400 threads, and we are using all the servers to generate it, and it's still the processing time we need to optimize, but it's a lot of data, so it's a quite tricky problem. And I will zoom in here in England, and we can see this is the land cover class, so we can check where is the coniferous forest, broadleaf forest, urban areas, and I will zoom in here where we can see the forest areas, and it's possible to analyze and to check the result of the classification. So this is the output of a machine learning model that we are training. And to training this machine learning model, we are using different training samples. So we have like these points that were obtained in the field and from other mapping products that already exist to the Europe. And for all these points, we have the class. So we use these points to actually teach the machine learning how classify and to identify in a satellite image what is a forest, what is pasture, and things like that. And this is the final product. So like the final output, the hard class, but we can check for all the classes. So I will show here the coniferous forest. We can check the probability. So we have like a hard class that it's like a post-processing approach that actually attributes like what is the final land cover class. But it's possible, for example, for some pixel, we could have like a mixture of land cover. So it could be part of forest or part of, I don't know, pasture. So we have this probability to help and to understand this, the landscape basically. And I will show here an example of the some type of validation that it's possible with this data. So here we can see the land cover, the coniferous forest, and I can turn on the Google satellite image. So it's a high resolution image, and we can see that it's possible to really the map, it's really capturing the landscape aspect, and we can check it. So it's possible, for example, use like Google Street View to actually see if the data it's correct. It's what we are doing now during this month, is to release the final version. So we check the results and we improve the machine learning. We put more points and we create better models and to generate a second version and produce a better product. So it's easy to see here that actually I can zoom in and it's possible to actually see where I'm pointing here on the ground, and it's really a coniferous forest. So the machine learning, it's working pretty well here to capture this this land cover class. And we have it for pasture and for 33 class across Europe. So yeah, so I will show there is some place that we can actually see this change. So here is an example in how it looks like in 2019 and how it's in 2000. And we can see that we had more forest here in 2000. And if I put here 2090, we can see that we lost some of the part of this forest, and it's easy to see how the landscape changed across these 20 years.
That's the south of France, and I think it's an area where they had a plantation, probably eucalyptus or something. So that, and then probably they decided to change that. So that's my estimate. That's why you see so many changes.
So in terms of takeaway information for someone, you mentioned their loss of carbon per square metre, but what other information are these maps telling us, and how can that be used for good?
We have a feeling that this is, and we really hope that this is going to change. So the governments will start doing more and more legislation to really monitor the land and monitor the fluxes. And one of the most important fluxes is the carbon fluxes. And what we think is going to happen, that it's going to become, multi-billion dollar business or euro pound business. And so the governments will want to see, and they will reward people for doing carbon sequestration, for example. So there will be rewards, and there will be more and more carbon taxes. So there will be kind of carbon crediting system. And in this system, it's going to be very important to monitor and then to predict, what's the best way and what is the potential. And you will be able to do that per pixel. You'll be able to follow that. And then also, many projects are now interested in land restoration. And land restoration means, some land which was like through urbanization or through intensive agriculture has been really degraded. So how do you restore that soil? How do you make it again healthy? And so there's all these land restoration projects. And then anybody who invests in that would like to see, okay, how did it really work? If you do reforestation, land restoration, is it working? And it's really fundamental for any spatial planning department. It's fundamental for agriculture sector, agriculture business. Then also for investors, if the investors wants to see later on, what is the potential, what's the optimal land use. So there's a very broad range of potential clients. So that's not an issue.
Well, it sounds like there is a lot of information being captured here. So could you talk us through how you process and work with this data?
We noticed that there's more and more data, as I told you. The data is going exponentially. So we started putting all this data together. And then we noticed, okay, now we have millions of points and we have, terabytes of data. And we noticed, okay, now it's not only coding. Coding cannot save you anymore. You really have to get hardware. And then we also noticed, because we feed these global models, even space-time models, these models, just the model parameters, they're hyperparametric. They have so many parameters. So the models are like gigabytes. And so we noticed, okay, we need a lot of RAM also. We cannot just, have a small RAM. We're moving towards 1 terabyte of RAM now. So, we wanted to find the hardware that matches the type of problems we have. And that's how we started looking for this customized server. So we want to customize our server. And we know exactly which chips we want to use. We know exactly what are the bottlenecks, the RAM, the speed of reading. And that's how we came to Scan, because we said, okay, we can customize nicely servers. And your support at Scan was very friendly. So very happy with that. And they have their own AI lab. So that's a very good idea. So we could talk about the topic. So it's not only just a salesman, but people that understand the AI and machine learning. I like that they have a specialized departments, that they understand the fields, because you don't buy computers just to warm up your room or something. It's you really need the people who understand the applications. So that's one advantage of Scan. I think it was very easy to customize server via the scan website. And also we could always contact the scan colleagues and ask for question. And so that was all advantage of scan, yeah.
So what hardware are you using then to handle this data?
Well, we use, we have different solutions. We have the servers for storage because it's a large data set. So we have now one solution where it's with a 20 terabyte SSD server. So this one is just to serve the data, so you can do point overlay, and you can do subset, so you can access data very quickly. Then we have servers to do computing, so that's where we do either model fitting and prediction. And then we have servers where we use for publishing. So these are like 3 groups of servers. The one for publishing, we don't want to make our own, so we just pick up a company to do the web hosting and web publishing. And there we can easily dedicate a cloud solution. But we use the scan service we use basically for modeling and for prediction. That's the heavy computing part.
Basically, our workflow it's working on CPU. So we need to optimize all the levels of softwares, and Intel has like a specific implementation to optimize the numerical operation in a low-level library called Intel MKL. And we did some tests, and we create like our own benchmark using our own data. So it's an important part of the optimization process, because you can find some ready to use benchmarks, but it's not could be not really adequate benchmark for a specific case, as our case. So basically we tested it, and we optimized it using this Intel MKL that it's compatible with Intel CPU, and we noticed that it's 3 times faster than, for example, solutions running in AMD. So it's really important to us, this optimization, because it will reduce, for example, the computation time in 3 times. So, for example, if we run for 5 days in an Intel CPU, it will take 3 times more if we run in other way. So we try to optimize and create this customized benchmark, and specifically for our use case, and optimizing all levels of software and hardware.
So why did you opt for a CPU server over a GPU server, and what are the specifications of what you're using?
Yeah, right now we have our customized workflow. So basically we are using more conventional machine learning algorithms, like as random forest and other algorithms like that. But we know that there are some possibilities to use GPU to process this remote sensing data, and we need to explore it. And but right now our production workflow, it's already implementing like libraries that use more CPU and are more compatible with CPU. But we are investing to incorporate this GPU in our workflow, and I think the future solution for our case, it's really create like hybrid systems that combines, for example, GPU and CPU, using, for example, all the memory that we have available in the not only in the GPU, but in our machine. So, but it's an investment considering the solutions that we have available now.
What advice would you give to other businesses about investing in machine learning and AI?
So number one is start buying a one server or like a smaller version, and then build up from there. Of course, so invest very carefully. Also diversify. We do have also GPU and CPU servers, so you diversify from the beginning, and you consider that there are many ways you can reach a goal. Then benchmarking. Nothing can happen in, I think, machine learning with like good benchmarking. And when you benchmark, you have to benchmark all the processes. So don't forget, because we notice now it's so sensitive. I mean, you have this workflow of, doing multiple things, and in that workflow, you can have one bottleneck. So it's just so let's say it's just a migrating data or just reading data from, or splitting data into many tiles. And it's just a one bottleneck. And if you make a mistake there, your whole process is in danger. So yes, start testing, diversify, benchmark, and then scale up. Only then scale up, yes.
It's certainly all very exciting. So what's next for you guys?
Well, there's a lot of exciting projects coming up, and we're doing some regional projects, but we're also doing some global projects. We have a very high enthusiasm for crowdsourcing projects, and that's where because we make these global data sets, but we would like that this data is available to people on the field. So when they open their mobile phone, they can access all that. So we want to connect that segment from, going from somebody with a mobile phone to the data in a cloud or on some server. So we want to connect that whole cycle, and we would like that actually people on the field do the determination of species, so measurements, soil scans, and then they contribute that, and it goes. My dream is to have that going automatically in a system, and then the system automatically recalibrating all models. And so that's something like local data, global models, and being automatically recalibrated. And maybe in some future, I don't know, 20 years, it will be just a one intelligent system that will just tell us, guys, be careful, there's something going on. So the system will detect things in the environment, some negative trends, and it will have automatic warning. Because obviously we made a mistake with the global warming. We kind of underestimated it. We didn't know about it. And we need to prevent that. The only way to prevent that if you have a better model so that you can predict what's the effect of that in the future.
Excellent. Now, what is the ultimate goal with this? I know that both of you are incredibly passionate about this, but how would you like to see all of this data used in the future? What is the ultimate goal?
Well, yeah, we believe in, so on the end, it's very simple. We would like to have a restored land, restored ecosystems. Also super simple, greener planet,
To do it, we need to combine high processing computing. We need to combine new machine learning algorithms, more reliable data, and we need to put all these solutions together to really generate the most reliable information to helps to really take the right decisions and promote more sustainable solutions. Considering the current solutions, we can do it. We just need to have political willingness to get this and actually have a more greener planet.
Brilliant. Thank you so much to both of you for your time today, for the great demonstration, and of course for all the great work you're doing.
Thank you so much, yes.
Thank you.
Thank you for your questions.
If you're interested in how AI and machine learning is being used within different industries, then check out our Inside AI series, where we explore different technologies and how they're being implemented across all business sectors. And if you'd like to talk to someone here at SCAN about your AI and machine learning projects, contact the team today at ai@scan.co.uk.